In today's cloud landscape, teams face mounting pressure because budgets are tight, workloads are growing, and new initiatives demand both performance and efficiency. Traditional cloud options often force compromises, either by paying more for high performance or accepting variability and constraints on scalability. Well, this is exactly where Vultr VX1 Cloud Compute fits in, providing consistent compute and flexible storage for demanding workloads. Hello everyone, I'm Sanskriti Harmuk, a developer relations at Vultr, and in today's Tech Talk, we will explore what Vultr VX1 is, discuss the problems it is designed to solve, and walk through the available storage boot options. Finally, we'll wrap it all up by demonstrating how to provision a fresh Vultr VX1 cloud compute instance, indicating how easily you can launch reliable, persistent, and high performance applications. So, without any further ado, let's get started. Vultr VX1 Cloud Compute provides dedicated CPU resources with configurable storage. It combines high density multi core compute with versatile storage options. Vultr VX1 offers 82% better performance per dollar compared to leading hyperscalers. This makes it ideal for applications such as web servers, SaaS platforms, databases, analytics services, and dev or test environments, where reliability and total cost of ownership matter more than peak single core speed. In short, Vultr VX1 is engineered to provide robust performance, adaptable storage, and predictable outcomes, enabling cloud native applications to run efficiently and reliably. Vultr VX1 is designed to address some of the core challenges of running cloud native workloads at a scale. By reducing noisy neighbor performance variability, Vultr VX1 ensures that each instance receives consistent compute, eliminating unpredictable slowdowns caused by other tenants on shared hardwares. Its decoupled compute and storage architecture allows CPU and memory resources to operate independently of storage, giving engineers the ability to scale and optimize each component without compromise. It delivers high throughput networking with minimal latency, enabling applications to communicate quickly and reliably, which is essential for distributed workloads, APIs, and real time data processing. Also, Vultr VX1's hyperdense architecture maximizes multi-core efficiency, allowing workloads to fully leverage all available CPU threads, which is particularly valuable for parallelized applications. Together, these design principles ensure that Vultr VX1 cloud compute instances provide predictable, reliable, and efficient performance, giving developers and teams a robust foundation for modern cloud native applications. Now, let's talk about Vultr VX1 and its storage deployment models, which give you the flexibility to match storage to your workload requirements. One option is Bootable Vultr Block Storage, which offers persistent, redundant, and encrypted volumes for operating systems and critical application data. This ensures that your data remain intact even if the instance is stopped or deleted, making it ideal for workloads that require durability, consistency, and the ability to scale storage without downtime. On the other hand, for workloads that demand low latency access or temporary high speed storage, Vultr VX1 supports local NVMe, providing extremely fast input output for ephemeral or scratch data. You can also combine both approaches in a hybrid deployment, placing the OS on a bootable Vultr block storage volume for persistence and using the local NVMe for high speed scratch or temporary application data. All these deployments can be managed via the Vultr customer portal or automated through the Vultr API, allowing you to provision, manage, and scale instances efficiently within seconds. Having explored the architecture, design principles, and storage options of Vultr VX1, we are now ready to see it in action. In this demo, we'll create a new Vultr block storage volume and use it to provision a Vultr VX1 instance. This will showcase how easily you can deploy an instance with persistent OS storage, ensuring durability and flexibility from the very first step. Let's look at how Vultr VX1 translates from architecture into an actual deployment. For that, We start by logging in into the Vultr customer portal, navigating to the compute section under products, and here clicking on deploy server. First, from the compute type options, we select dedicated CPU. Then we choose one of the regions where Vultr VX1 is currently available. Next, we select a compute plan. This is where Vultr VX1 differs from traditional dedicated CPU instances. In the storage section, instead of seeing a fixed NVMe or SSD option, Vultr VX1 clearly exposes a storage choice at provisioning time. You'll notice plans that list either block storage or local NVMe size, indicating Vultr VX1's decoupled compute and storage model. At this stage, you'll also see two plan categories. One is general purpose, starting with VX1G, which offers a balanced ratio of virtual CPUs and memory. These plans are ideal for web servers, application workloads, containers, development environments, and moderate database deployments. The other one is memory optimized, starting with VX1M, which provides a higher memory to virtual CPUs ratio. These are ideal for workloads such as in memory caches, analytic services, JVM based applications, and memory intensive databases. Now, when it comes to booting, if you want to boot directly from local NVMe, then you must select a Vultr VX1 plan with S suffix. These plans include locally attached NVMe storage on the host. So during configuration, you can choose an operating system that is installed directly onto this local NVMe disk, or can boot the instance from Vultr block storage volume instead. In this case, the block storage volume will serve as an OS disk, whereas the local NVMe will remain available as an additional high performance disk, creating a hybrid setup. And to boot exclusively from Vultr block storage, you can select a Vultr VX1 plan without the S suffix. For this demo, we'll move forward by booting from Vultr block storage, where the instance uses a persistent OS volume. Now let's switch to the configuration step. Here we have two options. We can either choose an existing bootable Vultr block storage volume from the list or create a new one. For this demo, let's create one from scratch. For that, click on Create Bootable Block Volume. Here, select the operating system and the preferred version, choose the storage size, and provide a label for the volume. Once that is done, create the bootable Vultr block storage volume and continue. Once created, make sure that the correct bootable volume is selected from the list. Next, configure server settings, such as adding an SSH key for secure remote access or applying a firewall group if needed. Further, set hostname and label for the instance. Then, from the pool of additional features, enable the one that you need. We'll go forward with limited user login. Once everything is configured, review the deploy summary and click deploy. Within 10 to 20 seconds, our Vultr VX1 Cloud Compute instance transitions to running status. Once it is live, open the instance by clicking on it. You can retrieve necessary details and manage your instance directly from here. You can also SSH into the instance to start working immediately. The view and operational capabilities of Vultr VX1 is similar to the other compute type you may have previously provisioned on Vultr. Let's also navigate to the block storage section under Cloud Storage and Products. Here we can see the newly created bootable volume listed. Open it and notice that it is already attached to our VX1 instance, since it is serving as the OS disk. From here, you can manage the volume independently of the compute instance. You can resize the block storage as your needs grow, detach it or reattach it to another VX1 instance if required. And that's how simple it is to provision a Vultr VX1 Cloud Compute instance booted from Vultr block storage volume. You can follow the same process to deploy Vultr VX1 instances using local NVMe or create a hybrid setup either through the Vultr customer portal or programmatically using the Vultr API. For more details, we recommend checking out Vultr VX1 Cloud Compute product documentation and the supporting reference guide linked in the description of this tech talk. To summarize, in this tech talk, we have seen how Vultr VX1 Cloud Compute combines high-density compute with adaptable storage, letting you launch and manage cloud-native workloads with confidence. If you are ready to try this yourself, then create your own VX1 instance on Vultr with a storage option of your choice by claiming $250 in free credits on a new account using the promo link attached in the description below. For any questions or to connect with other developers exploring Vultr VX1 deployments, join the discussion on the Vultr community forum. Thank you so much for tuning in. We hope this tech talk helped you optimize cloud native workloads with consistent high performance compute and versatile storage on Vultr VX1.